storm here, we created also a safety monitor. Imagine you are this policeman over here, and you have that large, big crowd in front of you, and you need to keep them calm and focused, and you try to prevent a large event where everybody is running around and there might be some victims. But you're in a small line and there's a really large crowd, so actually you want more people there. But that's not possible nowadays because the police is constantly reducing their cost, so people have to leave the police force. And this is actually creating a large pressure to the policemen. So nowadays you have to come up with new innovative techniques to deal with this lower amount of employees. Yeah. So we come up with a research question. Like I already said, we have to look at new techniques to improve it. Now the police is already starting a project with drone techniques, but now they are actually only using it to look at specific crime places after a crime is committed. So someone robbed a bank, for example, and they put a drone into the air to make sure that they can find this person. But what we said, we want to create something which is able to detect it before it happens, because preventing is always better than curing afterwards. So we came up with the question, how can we proactively deploy the drones to fight crime? Now, how did we do that? We created a safety monitor. And that's what we see the history. So we combine several data sets where the user can select a specific crime, a specific city. For example, now San Francisco is selected, and you can look into a particular year or month, and you can see all crimes projected in the crowd. So now Los Angeles is calculated, so you see Los Angeles. So this is really easily to scale up and add more cities too. So it can be really easily put into practice. We can also, besides this historical view, we can look at the present view. We do this by analyzing analyzing Twitter data. Can you go to present? Right. We see we have an update every 1 second, so the Twitter data is updating every second. And this is really useful because you can see clusters of people and you can see where there's a large crowd. The advantage of this is that if we detect a large crowd, the police can see, okay, maybe we have to move some police officers over there, or we can move a drone over there to take a look over there, and maybe we see some activities. Okay, besides the present, we can also go to the future, like I already said with drones. In this dashboard, we have a drone number of 5. It can be adapted, so you can put on 7 or 8 if you buy new drones. And you can actually do the same thing as before. You show the location. The location is being created on the map of all the crimes which you selected, and the algorithm predicts actually where crimes will happen at, for example, now 6 o'clock in the evening. And after the prediction is done, it will calculate the squares on the map, and that will be the perfect spot according to us, or algorithm, where we can best put this drone into practice. So if you put it over there, we have the best chance of detecting crime by, for example, with a camera. And if, for example, a robbery happens, we are already there. So that will be a really great benefit. So our conclusions is really good at locating the specific crime. It's easy to follow the person if a crime committed, and preventing, because sometimes a person see the drone and stuff.
Ik had je nog 6 seconden gegeven. Ja.
How does your prediction algorithm work? So where do the most car thefts happen or so? Does it look only at the global history or does it also look at recent events and features that in?
Yeah, it depends on the model. For example, the model I showed at the end with the future prediction, it looks at the Twitter data, which was shown in the view of what's happening now. So it combines that with the historical view. So it looks in the database what was happening last year, last month, and it combines it with the data, Twitter data, which is actually real time.
Okay, did you find really a relation between the amount of people in an area and the amount of crime happening there?
We haven't looked really at that specific thing. We put it into the model to create a prediction, but we didn't look at the correlation between the number of people and the number of crimes happening, number of people twittering.
Okay, thanks.
Yeah.
Yes, you're specifically using it now for drones, right? Do you also have other applications that the police could use it for?
Yeah, besides drones is of course really new advanced technology, but you can also say we can use it with stationary police officers. So where do you put police officers today around the city? Because you need to spread them across the city. You can do it also with the algorithm just by changing the number of drones by the number of policemen you have. You can run the same algorithm. You can really implement.
How does it relate to current systems who already do this but don't with drones interaction?
Yeah, just current systems mostly only look at the data which is already present.
Thank you. Give them a big applause.